Hi everyone. Today we are going to take a look at the third problem in blind 75 LeetCode questions. And the problem is longest palindromic substring. Given a string S, return the longest palindromic substring in S. What is a palindrome? Palindrome is a word which can be read the same forward and backward. For example, look at this BAB. So it reads BAB if you read it from the beginning, and it reads BAB if you read it backwards. And as I mentioned in the previous video, substring is a contiguous non-empty sequence of characters within a string. For example, in if you take this particular string, BAB is a substring, ABA is a substring, BAD is a substring, or BABA is a substring. But what is a subsequence? Subsequence is not a contiguous. What is a subsequent? Can contain elements not from a contiguous position. For example, a substring for this particular S would be A and D, AD. It could be a, or BD. It could be a subsequence. Today for this problem we are going to take a look at finding longest palindromic substring. How can we do it? Let's look at the constraint. So it states that the length of the string is at least 1, and S consists of only digits and English letters. Let's see how we will solve this. If you look at this word race car, this is a palindrome. It reads RACECAR, RACECAR backwards. So this is a palindrome. What we want to find out is the longest palindromic substring. Please note that we have to return the substring, not the length here. Okay, so how can we do it? So what would be the brute force approach? So it would be, we would generate all the substrings available from this particular string called S, and we'll check whether it is a palindrome or not. If it is palindrome, then we keep track of the biggest element and then return it. We can use the similar way we did in the last longest repeating characters, but here we will slightly choose a different approach. I'll tell you. So if you remember exactly how we did in the last problem, we started with RA, then we started with RC, like RAC, then we started with RACE, then RACEC, then RACECA, then RACECAR, then start with AC, ACE, ACEC, ACECA, ACECAR, like this. But what we want, this is perfectly fine, but I'm going to do a small change here so that we don't have to keep track of all the elements and find the one which is biggest. Instead, what we will do is we'll start from a bigger substring. So I'm going to keep this same, which is R, and check whether the full string is a palindrome or not. If it is not, we'll try A to R, like ACECAR. Then we'll try CECAR, and so on. Okay, once this is done, we'll start with this particular letter, and we'll start with RACECA, then this, then this, and then this. So if you look at it, if you find a string, so since we start with the bigger substring in the string S, That would be the answer. So we could easily do it. This would need two loops, because we need to start with this, and we need something start with 0 to length like r, which is 0, 1, 2, 3, 4, 5, 6, 0 to 6. Then we'll do 1 to 6 and so on. So the initial value would be starting from the length of the string, and then from length of the string minus 1, then from this, etc. But we also need a method to check whether a string is a palindrome or not. So let's take a look at how we would implement it. Okay, so let's write the first function, which is palindrome. So we are checking whether a substring is a palindrome or not. We will do start comma end. Okay, just to avoid confusion, let's do ing, and we are going to set the value as start and is equal to j. How will we check whether a string is a palindrome? Normally what we would check is check this value with r, a with a, c with c, and so on. So this is how we check. So in this case, the start is the first element and is the last element. What we are going to do is while left less than while start less than end, we want to compare the outer and then keep coming towards until it becomes equal. If s of start not, I think the start word is a bit confusing, because let's keep it as left and then right. So left, because it denotes the left element and the right element. Start and end is a bit confusing. So if s of left not equal to s of right, that means this is not a palindrome. So we will return false. Else what we will do is left will increase by 1, right will increase by decrease by 1, and return true. So we got this method to check whether this is a palindrome or not. And as we discussed earlier, let's do the loop. So we are taking length, okay, in range of, we'll start with the len of s, okay, and we are going to decrease it to 0, and minus 1 is when we decrease this. So the value is not would be in, if you take this particular example BABAD, the length of s is 5. So the first it would come 5, then 4, 3, 2, etc. 3, 2, 1. This is how the value would come. Okay. So the then we need another loop to find the starting position of the substring. It will be, if you remember it, from 0. So we don't need to mention it, because by default the value would be same. So we want to check okay, so the start will be in range of len of s minus length plus 1. So the start will start from 0 to 0, 1, 2, and so on. If is palindrome of, we are going to check whether start and start plus length, whether it is a palindrome or not. If it is a palindrome, we will return it, because that would be the biggest palindrome that we would get from here. So if we were doing it in the previous way, we will have to go through the entire entire smaller string and then keep track of it. So here we don't need to. If it is not, we'll just return say empty. Okay, what is this error? Oh, okay, so I just meant it to keep it as a comment. Okay, so let's try this. I see. Okay, coming back. Okay, so we actually had to keep the right as j minus 1 because the line of s would be, because it's a 0 based index, it starts with 0, so we can't access an element which is out of range. So let's try this. Okay, so this works, right? So what is the complexity here? So we have two loops here. This is order of n square, and we check this by checking each element once. So the time complexity is order of n cube. Okay, and what is the space complexity? Are we using any space? No, we are not using any additional space here, or we are using just constant space, which would be variable initialization and things like that. So space would be order of 1. Okay, let's take a look at how we can optimize it. So I'm going to reset the canvas. Okay, so let me write the example. So let me write one which is a palindrome. So race car is a palindrome of odd length. Let's take another palindrome, A, B, B, A. This is also palindrome, but this is even length. This is odd length. Okay, I'm just adding it because we could reference it. So what is the what can you note from this particular use case? Look at this. If you look at this middle, these two elements should be equal. Then only this can be a palindrome. We go beyond, A and A should be palindrome, and so on. So it's the same case here, only a small difference. In this case, we will check the B and B instead of in one single element at the middle. Then we check whether the elements on the right or on the left is equal or not. So from this you can make an intuition, or you can derive that this has sub problems. So this particular ACECA would be a palindrome only if CEC is a palindrome, and so on. If you remember, we can use dynamic programming to solve solutions like this. How can you solve? So what are the base cases? Okay, so if we kind of store the what is the intermediate result in a, say, in an array, what would it be? So we need the entire array, right? So we need two-dimensional array, one to store the start and one to store the end. For example, 0 0 is 0 0, like R, starting with R, ending with R. Is it a palindrome? Yes. Is this a palindrome? Yes. So this is the base case. And then we will take a look at, so this is single length, like a variable of, or the string of length 1. Then we can take a look at the double, or the strings of, for example, A. This is a palindrome, right? So we can check that, and we can use these base cases to build the build the other use case, like expand it. So if I have to say there is a dp. I'm going to call this array as dp, and dp of I and j. When will it be true? dp of I and j will be true when s is the string. If s of I and s of j is same, like equal, and dp of I plus 1 and j minus 1 is a palindrome or is true. So let me take an example here. Okay, so we are iteratively computing this. So we know that this is palindrome already, and we are at this state and this. So this is I and this is j. When will this entire string be a palindrome? Only if s of I is equal to s of j and s of I dp of I plus 1 and dp of j minus 1 is a palindrome, if this is a palindrome. So let's see how we implement it, okay, using dp. Okay, so I'm going to define an array called dp, and I'm going to set everything as false, like none of them are what do I say, palindrome initially. So for I in range of, okay, let me define a variable called n is equal to len of s. So range of n, okay, so for in range of n. So we got a 2D array. Okay, so in this case we need the starting or the ending index of the largest one, so that we could return. So result, I'm setting it as initially just 0 0, then we'll update it. Okay, so what do we know? So string of length 1 or palindrome, right? So let's set it. How do we set it? For I in range of n, dp of I is equal to true. So this is the base case. Then let's check for string of length 2. How do we check it? So for I in range of n minus 1, so I'm going to check every consecutive elements. If s of I equal to s of I minus 1, that means that particular string of length 2 is palindrome. So dp of I and I plus 1, so true, and we are updating the result as I comma I plus 1. So this is just a string that is palindrome, substring that is palindrome. Let's take a string more than 2. So for how we are going to do is, it's the same way we did in the brute force. For length in range of 2 comma n, so we already calculated those with 1 and 2 length, and we are going to check range of, so I is a starting point, so we have to check from 0 to n minus length. What would be the value of j? J would be I plus length, right? So we are going to check I comma I plus length, that those indexes, okay? If s of I is equal to s of j, if that particular element is same, and dp of I plus 1 comma j minus 1, if this is true, then this substring is also a palindrome, I comma j equal to true. we would also keep updating the value of I comma j. So since it starts from bigger element, at the end what we receive would be the biggest element. So what we know is, we know the result now. We have to return the string, right? So we will return s of let's so I comma j is equal to result. So I would be the starting. So I, then j plus 1. Why j plus 1? Because in Python the right side value is not an inclusive one. So if you add j plus 1, that is when everything would be like all the elements from I to j will be included in the substring. Okay, so let's try to run it and see if there is any bug. Okay, we have a small bug. Let's see. Okay. So we did this and oh, okay, sorry, there was a typo. So we are checking every elements, the consecutive elements. Okay, yeah, there you go. So we found this. Let's take a look at the time complexity. What is the time complexity? So this is order of n, this loop, and this is also order of n, and this is order of n square, because there are two loops and we are iterating. There is two passes actually. Sorry, not two passes, two loops. So order of n plus order of n plus order of n square. So the time complexity is order of n square. What is the space complexity? So we use this dp. So the space complexity is order of n square, because we keep all the options required for both I and j. So this is the space. Okay, so this is yeah, this is one solution. Okay, can we improve this? I'm going to reset it so that we could talk about it. So I spoke about partially on this earlier. Let's we could actually use a different method and try to, like, what is the problem with this particular solution? The space complexity, because the space complexity is small. Can we optimize it? How? Okay, so let me, yeah, I'm going to take the same example, race car. This is similar way that we found, but we don't use that much space. Okay, so this is an even length palindrome and this is an odd length. How about, okay, so we can, instead of storing this, what we could do is we can check each of the each of the element in the array as a middle element, and then try to expand it to see if it is a palindrome or not. And if it is a palindrome, we find the biggest one. How? So for example, we take E as mid, then we expand. This is same. So we expand to this. We expand to this until we can. Okay. So this is one way. So similarly, since this is palindrome, we just start with this. We could also do it with, for example, in the case of okay. So ideally, for odd length, what we would do is we will start with the same indexes. So if it is an odd number, so I comma I. Okay, and if it is same, we do I minus 1 and I plus 1. That is C and C. Whether it is same, we'll again go I minus 1, I plus 1, and so until we have hit the boundary here. In case of odd number, even number, what we do is we start with I and I plus 1. If it is same, then we go to I minus 1 and I plus 1 minus plus 1, I plus 2, and so on until we can. And we can do this expansion. So we only need to take care of odd length and even length, right? So ideally what we are trying to do is we are trying to keep each index uh, as a center element and then try to expand it and find the biggest number. Okay, so let's see if how we can implement it. Okay, so let me submit this and see if we missed any earlier test cases. Yeah, okay, so it passes. Let's come back, and so we need a method to expand, right? So we'll call it as expand, and the indexes are the input. We start with left equal to I, oh sorry, I, right equal to j. So we need to check the boundaries. Left should be at least greater than or equal to 0, and right should be less than len of s. We can actually do right less than len of s or less than or equal to len of s minus 1, and s of length left should be equal to s of right. We keep expanding it. Okay, so left will become left minus 1, right will become right plus 1. So when will this while loop exit? It will exit when it is not equal. So what would be the length of the palindrome? It would be, so if you remember, the actual length would be right minus left plus 1, but in this case the while loop we exited from the while loop when it is not equal, so we have to reduce the two elements on either side. So the return value is right minus left minus 1. What do we know? So we need similar way we need a variable called result to store the start and the end. Okay, now we need to check the odd and the even. So we have to start with the, we have to think like, okay, so there is an odd length palindrome in it, check for it. There might be an even length, check for it. So we are going to do it for I in range of, we have to find the biggest one. So we start with so we start with a loop, and how did I say we would do it? Odd length is going to be expand of, how are we going to do, I comma I. What would be the return value for odd length? Odd length value would be what do you say? Odd length value would be the length of the palindromic substring. So we are going to compare, because we will be storing the intermediate palindromic substring in this called in this result variable. If odd length greater than result of 1 minus result of 0 plus 1. We are checking whether the length is greater than the existing result. If length is greater, then we are going to find the distance. Since it is odd length, we'll say odd length divided by 2, and we will set the value as I minus dist comma I plus dist. Okay, because we expanded around I comma I. Hope this is clear. Let's see if there is any even length. Expand of I comma I plus 1. If even length, so we are checking again result of 1 minus, so this is nothing but right minus left plus 1. Distance is equal to even length divided by 2 minus 1, because this is an even length, and the result would be, if you remember, it would be I minus dist comma, we did it with I and I plus 1, right? I plus 1 plus dist. So this is the loop, and we need to return the result. So what we are going to do is s of I comma j plus 1. Okay, this is similar way. Let's try to run it and see if there is any bug. Okay, so let's talk about the complexity. what is the complexity here? So there is only one loop here, so this is order of n, but we do the expand inside. So the time complexity is order of n, in like n into n, like two loops, order of n square. And space complexity, we are not using any additional space. If you remember, in DP there was order of n square space, so we saved the space here. So that is the benefit of this, that is optimization that we did. So let's try to submit it and see if there is any edge cases. Okay, so it passed. Okay, so we have completed longest palindromic substring. Thank you everyone for listening or following along. Please let me know if you have any feedback. I'll keep posting the Blind 75 playlist, and if you have any suggestion for the way I talk, or what we need to talk about, or what videos do you need in the next episode or playlist, please let me know. Thank you so much, and see you soon.